Hello everybody and welcome to your review video. So you guys have your team test tomorrow, and so this video is just going to go through and review everything we learned in chapter 1 and make sure you guys are clear on what exactly I'm going to be asking you guys to do on your team test. So if you remember, chapter 1.1.1 was just the quilt thing. So that was just talking about symmetry and introducing that to us. We skipped 1.2. And then we started diving into more of the math in 1.1.3, where we talked about different patterns. You guys had to go through here and continue the patterns here and just start to understand what was going on there. There's really not going to be any questions about patterns or designs on your team test. We skipped 1.1.4 and we moved on to 1.1.5, which was really the introduction to the big ideas here. This is when you guys had your mirror, and the mirror was on hinges, and you guys got to move it around and make different shapes and really talk about the symmetry of those different shapes. We also talked about angle measures, so you would move the mirror in different angle measures and talk about the symmetry there. So the big part that you need to know about like the angle measures and symmetry is first, what shapes have symmetry, which is also something we reviewed later on in the chapter, so we'll talk about that when we get there. And then what your 90-degree rotation, 360, 180-degree rotation would be. So there's not many examples from this lesson in ways of what are the angle measures or anything like that, but it was a good introduction lesson to start talking about symmetry. So if you remember symmetry, we think about mirroring the image. So that was a big idea from that lesson. Then we moved on to 1.2.1. Which was started by building boxes, and then we really talked about reflections. So if you remember, reflections was our first thing we learned about transformations. So transformations is our umbrella, and then reflections, translations, and rotations are all underneath that umbrella. So you guys rotated these words around, or you reflected the words around. So just making sure that you know what a reflection is. If you are looking at your examples, let me find one here. Here are good ones. So remember, your reflections keep, if you have a point, let me pull this up. Alrighty, so let's say you have your grid here. If you have a point here, and this is point A, and you're reflecting it across the y-axis, it should be that same distance away from the y-axis. All right, so this distance and this distance are equal to each other. Okay, so that's the reflection aspect of it. All right, if you're reflecting it over the x-axis, again, they should be the same distance away. So you're just reflecting it over. You're using your mirror image and just switching it over. So that was a reflection. Then 1.2.2 talked about rotations and translations. So remember, rotations are the hardest ones. But a translation comes from when you reflect an object over two parallel lines. So that was that first problem you did. You reflected this image over that line N, and then you reflected it again over P, and it became the same image again. So translation does not change your image at all. All you're doing is sliding it. So when you think about the word translation, you just want to think about sliding your figure. And then a rotation came with this example, 160, where you were actually reflecting it over two lines that were not parallel. So you reflected it here, and that's what made that rotation. So if you are translating, you are just moving your points, you're adding or subtracting that amount of spaces it's telling you to translate. So if it says up 3, you're going to add 3 to your y. If it says right 2, you're going to add 2 to your x. So all you're doing is moving that. And then reflection or rotation, if you remember, if I have this point, let's just call it -6, 2. If I have that point and I want to rotate it 90 degrees clockwise, that means it's going to be over here. If it's 90 degrees, it switches places. Your y becomes your x becomes your y. Then all you have to do is figure out, hey, what's negative and positive? Since we're going into this first quadrant, everything is positive. So you're going to go over 2 and up 6. So it'd be maybe right there. If you're rotating it 180 degrees, so let's say 180 degrees counterclockwise, which means it's going to come down here, you don't switch your points at all. Your x and your y stay the same. Again, all you have to do is figure out which one's positive, which one's negative. Over here, your x's are positive, so 6 stays positive. Down here, your y's are negative, so that becomes negative 2. So you go over 6, down 2, and there's your new point. So every 90 degrees, you're flipping your points. You're switching your points. So if you're going 180, you're going back to your original point. So that was the big idea behind rotations. So you guys have a couple problems about, or one problem about rotating, 2 problems about translation, a problem about reflecting, and then we get into another problem about rotating, and then reflecting. So let's move on to 1.2.3, which was slopes of parallel and perpendicular lines, which is also a concept that you guys are going to have on your quiz. So if you remember, parallel lines, same slope. Parallel lines, same slope. They're never going to touch. Perpendicular lines have opposite reciprocal. So you're going to flip-flop your fraction and change the sign. If it's positive, it becomes negative. If it's negative, it becomes positive. So you guys did this whole lesson. If you rotate something, if you rotate an object 180 degrees, remember your points are staying the same. So on 180 degree rotation, your points are staying the same. Your y's and x's are not flip-flopping, which means your slopes are going to be parallel, which is what this whole problem was talking about. If you are rotating something 90 degrees, like this guy right here, those lines become perpendicular. Okay, so just remember that stuff for your team test. You're going to be able to rotate those problems and actually understand where the lines are going. So all of that stuff should be clear for you guys. I don't think that there's going to be a problem there. Just remember the big idea here is that parallel lines, same slope, perpendicular lines, opposite reciprocal. Alrighty, then 1.2.4 was defining transformations. So again, this was all just more practice about transformations. So transformations is our umbrella word. It covers rotations, reflections, and translations. So you guys remember doing these problems. I gave you guys that worksheet as soon as you walked in the door and you guys started working on that. Then you guys just went through more translations and working through all of those things. So here are the actual definitions for reflections, rotations, and translations in case you want to refer back to that at all during any point. We skipped 1.2.5 and moved on to 1.2.6, which was talking about symmetry. So you guys went through this and talked about reflection symmetry, which is where if you fold something in half, it's going to line up with itself. So that's reflection symmetry. Rotation symmetry is the idea where you can rotate something. Let me see if I can pull this up. You can rotate something and it's going to line back up with itself. So that guy has rotation symmetry at 120 degrees. Let me just get it there. This is much harder than it looks. Well, you guys get the gist. It's 120 degrees, and then if you keep going again, it's going to be at 210, 240. So that guy, all you do is take 360 and divide it by 3. If you had a square, you'd take 360 and divide it by 4. If you had a a pentagon, you'd take 360 and divide it by 5, and that's your rotation symmetry. That's how many degrees it takes to get you back to your original figure. And looking at the quiz, I don't think we talk about rotation symmetry at all. So just making sure that you're clear on what rotation symmetry is. I will not ask you, hey, what is the degree of the rotation symmetry on your homework quiz? So do not worry about that. Don't stress about that. So we talked about reflection symmetry, rotation symmetry. Don't worry about the translation symmetry at all. That one's pretty self-explanatory. So we should be good on that. And then here, again, it talks about slopes of parallel and perpendicular lines. So if you guys need a refresher on that, it is in section 1.2.6. Then we have 1.3.1, which was just our shape bucket. So these are all of our Venn diagrams and our shape buckets and understanding what shapes have in common, what they have different. Remember, some of us were still getting confused in our Venn diagrams on the last homework, or the last exit ticket, I should say, the last exit ticket. Remember, a shape can only go in the Venn diagram once. So if you decide to put square in the middle of the Venn diagram, you cannot also put square in number 2 and number 1. Okay, if you put the square in the middle, that means it's in both circle 1 and 2. Okay, so this is all just your shape bucket. Referring back to shapes, knowing whether they have reflection symmetry, rotation symmetry, has a right angle, has 3 sides, all of that fun stuff. And then 1.3.2 was basically an extension of that. We had more Venn diagrams. We were describing shapes. You guys had to learn, or you guys did that activity where you describe shapes without using the name of the shape. You guys got your nice purple shape bucket with all of the parallel lines, right angles, equal sides, the names, the definitions. For the test, I have decided that I am going to give you this sheet right here. All right, so for the partner quiz, I will give you this sheet right here. So that way you still need to have a little understanding of what's parallel, what's perpendicular, what's same lengths, but you at least have the name and the picture in front of you. So even if you're not 100% sure, and maybe you say, we're looking at isosceles triangle here, you know, okay, those sides look pretty similar. I think isosceles means both sides are the same. Equilateral means all 3 sides are the same. So I'll give you this page, but it won't have all of that nice stuff like I gave you on that purple sheet. Just because I want to see what you know and what you don't know, and you're not going to have this on the state test, so it's good to start practicing without it now. So there's that, and the final thing, so there is 2 questions on your group test about your team test about placing things in the appropriate Venn diagram. So just making sure you know which ones have parallel lines, what's a quadrilateral, what's an equilateral, all of that fun stuff. Alrighty. So I will see you guys tomorrow then. So please make sure you guys are looking over that purple sheet for your team test. Other than that, please don't stress out about the team test that much. You guys have 4 people working together to take one test, and I think it should be okay. Use this as practice for your individual test. If there is something that you're not understanding, you as an individual, write that down maybe on a piece of paper as you're taking this team test and say, hey, I still wasn't quite sure on the Venn diagrams, or I'm still really struggling on rotations. Write that down and make sure that you guys are practicing that before the individual test, which will be next Friday. Also, come see me if you guys are struggling with anything else. Other than that, I will see you guys tomorrow, and have a great night.